All right, let's keep looking at functions as we consider writing a function rule. And this is our objective for this one is to write equations that so we're going to write equations that represent functions, represented by equations. You can use an equation to find the solution of a given real-world problem. So this is where we're going to take an application situation, turn it into a rule so that we can solve it. In problem one, let's talk about insects, because why wouldn't we? You can estimate the temperature by counting the number of chirps of the snowy tree cricket. Okay, that's just cool. The outdoor temperature is about 40 degrees Fahrenheit more than, than 1/4 the number of chirps the cricket makes. Okay, the number of chirps the cricket makes in 1 minute. Okay, what is the function that represents this situation? Okay, when I think of take out the extra words and put it in here, I'm seeing that the temperature is 40 degrees Fahrenheit more than 1/4 of the number of chirps in 1 minute. So we're going to write our let statement. So let T be the temperature, let N be the number of chirps that happen in 1 minute. And our equation plays out like this. So we can say the temperature is 40 degrees more than, so we're going to be adding this on, 1/4 of the number of chirps. So we've taken our sentence and turned it into an algebraic sentence. And you can see it play out there. The function rule represents this situation. If we pull the spaces out, we can see that T equals 40 plus 1/4 N. The temperature is 40 degrees more than 1/4 of the chirps that happen in 1 minute. So if you count the chirps times 1/4 plus the 40, you will indeed find your temperature. We can see that a model can help you visualize what's going on as well. Over here you can see that the whole temperature is really saying that it is 40 degrees more than 1/4 of the chirps. All right. Press pause. Let's see how you do on this one. Write your sentence first, kind of pull the words out, get your let statement played out, and then let's see how your equation is. How'd you do? Total waste is 50,000 plus the 420 per month. And you can use this equation to determine what's going on each month and how much is in the landfill. Let's look at writing and evaluating a function rule here. All right, let's look at a couple things we know. A concert revenue. So a concert seating plan is shown below. Okay, reserve seating is sold out. So that's an important piece to be aware of. The total revenue, so I'm looking for that from ticket sales, will depend on the number of general seating tickets sold. Okay. It's going to depend on the number of general seating tickets sold because reserve seating is already sold out. Okay, we're going to write a function rule to represent what's going on. Now we're looking for the total revenue. So we're going to play this out. So we'll have R be our revenue. Okay, we're going to need a couple more variables here. We could do number of seats sold, so maybe we can do S for seats sold. Okay, now let's take a look here. So, so my total revenue is general seating plus and the reserve seating. And those two together should end up creating my total revenue. So let's play this out. So my total revenue is my general seating. Let's take a look at my general seating. Looks like my general seating is going to be $10 per seat, 30 rows, and 16 seats, but we actually don't know how many has been sold, so it's $10 per seat with S seats sold, okay, plus my reserve seating, which is sold out, so that's going to be all of this, so that's going to be my $25 per ticket times the 10 rows times the 12 seats per row. I can simplify this a little bit. So my total revenue is going to be however many seats I sell in general seating plus um, my 25 times 10 times 12, which is like $3,000. And if I look at the actual general seating itself, if I do play that out, I do see that my general seating is going to be, let's see, let me look at the rows again. 30 rows, 16 per row at 10. So it's $10 at the 30 rows, and there's 16 per row. So if we look at the 10 and the 30, I'm going to get rid of the 10. If we look at the 30 and the 16, look at those two things, we can see that's about 480. About 480 seats sitting in there. So we could finish this out by saying that my reserve seat is 10 times the 480 seats plus the 3,000. So my revenue, my total revenue when this whole thing plays out, and I simplify this whole thing, is 7,800. It's a good chunk of change for listening to crickets sing. Find the temperature. Why don't you try the kennel charge? Press pause and see what you do. Our equation is the total cost is $15 per day and the flea bath. Does the $5 a day cost, does it stay half as much as a 10-day stay? No, it doesn't. A stay shorter only has the daily charge, not the bath charge. So we're going to wash those fleas off no matter how long they stick around. We're going to write a nonlinear function rule. All right, let's look at the general rule of this rectangle. So we have the length and the width, the area being length times width. Let's look at this particular triangle or rectangle. All right, so this particular rectangle is saying the length is 5 more than its width. So if I know its width, its length right here is 5 more than its width. So it's 5 more than its width. And I'm considering the area of this. I'm going to need to find my function first before I answer this particular question. So the area of my rectangle number 2 is going to be my length, which is w plus 5, times all of that times my width. So my area is, I'm going to distribute that out, w times w plus 5w. So my area for my new rectangle that I'm looking for is width squared plus 5w. Now I can answer the second question is, how about if the width is 9 feet? Well, now I know what it is, so I can plug it in. My area is 9 feet squared plus 5 times 9. Area is 81 plus 45. So my area of my new rectangle is 126. I don't know the units, so I'm just going to say units squared. All right, why don't you give it a try? There's a couple different ways to solve this. I started off with what I know about triangles, area being 1/2 the base times the height. And then I used my information. I saw that if my base is b, my height is 4 more than double the base. And so I include my formula. My area is 1/2 base times my height is 4 plus 2b. And then I played it out. I had to distribute my base, multiply that by 4 plus 2b, and then I had to distribute the half. And some of you can find a shorter way to do that as well. Is this situation linear? The graph is not linear. It could show out on a table as not a linear relationship, but it shows that on our graph and that the line does have a curve to it. All right, thanks so much for trying. I'm going to go ahead and find a new best friend at the circus. I'm kind of looking for somebody who is Oh, maybe I can find like a left-handed new friend. I need a left-handed new friend from the circus.